so this video is going to be part 2 of lesson 3, and lesson 3 was finishing off permutations. Part 1, you guys, we were doing permutations with restrictions, and what this part is going to be on is something that we have not done, so this is going to be brand new for you. This is permutations with something called repetitions. Okay, and right away, well, we'll do one class example to start with without a repetition, and then I'll show you right away what a repetition would look like. Okay, so off to the side, I want you to write the word rows. So off to the side here, I want you to write the word rows. Okay. And you would say right away, okay, rows is 4 letters. And if I said to you, how many different 4-letter permutations or arrangements can you make with the letters in the word rows? You would have said, okay, the different ways that we could have done this. You would have said, well, rows has 4 different letters, which represents 4 different stages. And then you would have said, there's 4 choices that could go there, 3 choices here, 2 and 1. And you would have multiplied that together, and you would have said, rows, with the letters rows, I could make 24 other words. So 24 other words or arrangements or permutations. They actually have the 24 different permutations right down here. So they took the word rows, and then they switched the S and the E, right? To make R-O-E-S. And then here, what did they switch? They switched the O and the S. And there's 24 different ones. So you'd never be asked to do this, but this is the word rows, the 24 different permutations of the word rows. Okay, or you could have said for this question, so you could have done it fundamental counting principle, you could have done it as a factorial. So you could have said or 4 factorial. And 4 factorial, simply 4 times 3 times 2 times 1, which would be 24 different arrangements or 24 permutations. Or you could have written it as a perm using the formula, which is NPR. And that would be 4 choose, or not choose, we're doing a perm, 4 permute 4. So there's 4 letters, and we're permuting 4 of them. There's 4 different stages. I'm going to erase that and put 4. Okay, so that's that should be a review, the word rows. Now, let's say I change the word rows, and instead of giving you the word rows, I give you a letter with what's called a repetition. So a repetition would be a word like Ross. And I said, well, how many different arrangements can you make with the word Ross? There is a repetition in Ross. There's 2 S's, right? And I've never given you up to this point a word with a repetition in it. So with rows, what they had done with this first one was they interchanged the S and the E, and it made a brand new word. But if I interchange the S and the S, is that the same word, or is that a new word? If I interchange the S and the S, it's the same word. So if we have a repetition, do you guys think I'm going to have 24 different arrangements, or would I have less or more? What do you think? You'd have less, because watch this. So they took Ross, and then they interchanged the S and the S, and they got Ross again, right? So, like, this is a repeat, right? They could do RSOS, and then they would get another repeat. So whenever you have a repetition, what's going to happen is you're going to have repeats, and we have to deal with the repeats. So how we deal with the repeats with a word like Ross is how you're going to calculate it is you're going to say, okay, what was the total number of letters that can possibly be arranged? And that answer is 4. There's 4 stages. There's 4 letters that could possibly be arranged. And then you must divide it by the number of repeats. So there's 2 S's, so I would divide it by 2 factorial. 4 factorial is 24, and 2 factorial is 2. So when I give you a word like Ross, and I say how many different arrangements are there, ROSS would be considered the same. There's only 12. So as soon as you have a letter that repeats, your number of arrangements decreases. Now let's calculate this word, RSSS. So if I said, okay, how many different arrangements can you have? And we've got 3 repeating letters. You would say 1, 2, 3, there's 4 stages or 4 letters total. And what you would divide that by, there's 3 S's. So that would be 3 factorial, 4 factorial is 24. 3 factorial is 3 times 2 times 1, which is 6. And now you're down to 4 different words. Because as you can see, all of these are the same, right? So we can only count 1 of them. And there'll only be 4 total. So that's how we deal with repeats. If I give you a word with repeats, do not use the fundamental counting principle, okay? This is how you're going to deal with repeats, is this method here, and you'll never get it wrong. So let's flip and let's look at class example 6. Okay, before we get to class example 6, actually I think I have this on a different page right here. Okay, so just highlight again the word repetitions. This is the formula to deal with repetitions. It is not on your formula sheet, and I don't say to kids or students, put this on your study sheet. You guys will know how to deal with repetitions. Like, it is going to be, you will have no issues dealing with repetitions. I'm just looking for. Okay, so N represents the total number of letters that you're arranging, right? So you count up always the number of letters. And then the A factorial, B factorial, and C factorial, this deals with the repeats. So for example, A factorial could represent if you have repeating S's. And then let's say in a letter you had repeating D's in your word. That would be B factorial, okay? So let's look at this for find the number of permutations in the letters of these 2 words, Vancouver and mathematical. So how you want to do this is, first thing you're going to do is you're going to count up, as always, the number of letters in the word. So Vancouver has 1, 2, 3, 6, 7, 8, 9. So there's 9 total letters that we're arranging, so that would be 9 factorial. If Vancouver had no repeats, we would be done at 9 factorial, but there's repeats in Vancouver. So what are the repeats in Vancouver, Haley? What do you see that's repeating? V's. And how many are there? 2. So just right off to the side, that there's 2 V's. So we account for the repeats in the denominator. And then on your calculator, you're going to type in 9 factorial and divide that by 2 factorial. And you will get your answer. So I'll give you a minute to get that. 9 factorial divided by 2 factorial. Jada, what are you getting? Yes. Sorry, did you say 440 or 444? 440. Okay. So the answer should be 181,440 different arrangements or permutations could be made with the word Vancouver, accounting for that there's repeats in the word Vancouver. Okay, count up mathematical. Angel, how many letters are in the word mathematical? 12. 12 factorial divided by. There's a few different repeats. So you would say there's an M and an M. So I'm going to write 2 M's. Kyle, what's another repeat? The A's. Okay, Kyle, how many A's? 3 A's. And then, Adam, anything else? How many T's? 2 T's. Okay, so let's account for the repeats in the denominator. There's 2 M's, so 2 factorial. There's 3 A's, so 3 factorial. And there's 2 T's, 2 factorial. Put that in a bracket. So whenever you have more than, we've got an operation happening down here, right? So it's 2 factorial times 2 factorial times 2 factorial. Make sure that's in a bracket on your calculator. Then you're gonna get a really big number in the millions. And double check or confirm my answer. But I get that there would be 19,958,400 different permutations can be made with the word mathematical. So this always tends to be a diploma question. Like this is a guaranteed diploma question that they'll give students. And then, so for you, guaranteed will be on your test, right? I'm just gonna take a big word with a whole bunch of repeating letters. And then you guys figure out the number of permutations in that word. Class example 7. Brett bought a cartoon, or a carton containing 10 mini boxes of cereal. So sometimes, like if you guys go camping when you were little, your parents might have done this. You could buy these like 10 mini boxes of cereal. And there's 3 boxes of cornflakes, 2 boxes of Rice Krispies, and then like the favorite cereal of kids, they only give 1 box. And then if you have siblings, they fight for this box, right? 1 box of Shreddies, and then your mom's not gonna open up another 10 pack until all 10 of these are eaten, right? So just part of being a kid. Okay, how many different orders are possible? Now, without reading this one little restriction that they're gonna tack on at the end, here's how most of you do this, okay? And then what we'll do, we'll fix it with the restriction. So first of all, 10 boxes. So let's actually write this off to the side. So there's 10 boxes of cereal. And let's write what was in the, how many little boxes of each. So there's 3 boxes of cornflakes. So let's write 3 CF for there's 3 cornflakes. There's 2 Rice Krispies, RK. There's 1 Cocoa Pops. There's 1 box of Shreddies. And then it says the remainder are Raisin Bran. So Maria, how many Raisin Bran would there be? 3. Yes, so that's the first thing, right? They're gonna expect that you're able to figure that out. Because if there's 10 boxes total, this accounts for 7 boxes, and then it said the remainder are Raisin Bran, so therefore, there'd be 3 Raisin Bran. That's how you do that. Okay, without reading the restriction of what they're gonna tell us to do, how you would do this question is just like the word mathematical. How many boxes of cereal total? So you guys can just watch up here, or you can even write this down and then you'll just cross a couple things out and we'll change it after. If there was no other restrictions, and I said, how many different ways can you like eat this cereal, 1 box a day or something like that, you would say, okay, 10 boxes total, and then you gotta divide it by the repeats. So you'd say there was 3 cornflakes, and there was 2 Rice Krispies, and you would say there was 1 Cocoa Pops. Oh, we don't have to put the 1, sorry. There's 1 Cocoa Pops, 1 Shreddies, and 3 Raisin Bran. So if the question just was, how many different ways are there arranging that you could eat 10 different boxes of cereal, or 10 boxes of cereal, this is how you would do it. But then what they say is they're gonna try to make this question more complicated. And they say, how many different orders are possible if on the first morning he has Raisin Bran? So what they're doing is they're saying on the first morning, he's gonna pick a Raisin Bran, right? And there's really, like, he just picks a Raisin Bran. So what that means is Raisin Bran is out of the pool. Like what he picks on the first day it's out of the pool now, right? We don't even really consider that. So this 10 boxes of cereal, if Raisin Bran is gone, how many boxes truly are there to arrange? There's 9. So because he's starting with Raisin Bran, right? So I'm just like, that's what he's starting with. That would be like starting with the letter N, right? You just say, okay, you take that out of the pool. Raisin Bran, 1 Raisin Bran is gone. So this changes to 9 factorial. And there's one other thing I have to change. If a Raisin Bran is out of the pool, there's something down here that has to be changed. Gabby, do you know what it is? Yeah, if he started with a Raisin Bran, right, you just take that guy out of the pool, it's gone, you're not even considering it. So I'm gonna subtract 1 Raisin Bran. So that means we're only dealing with 2. So this would actually be a 2. Put that in a bracket. And there's only 9 boxes of cereal that he's truly arranging. 3 factorial times 2 factorial times 2 factorial. One sort of just aside that I want to make. Do you guys truly need to type in a factorial for the 2? No. So you could type in 3 factorial times 2 times 2. Or, to be even quicker at this, what is 3 factorial? Yeah, most of you should be able to do that in your head. 3 factorial is 6. So 6 times 2 times 2, right? If you want it to be faster. Or you can do 6 times 4. Just make sure that that's in a bracket. And then what you would get for this is you would get, how many different, 15,120 different orders are possible. I'm going to write arrangements. Arrangements are possible. Okay, last question. Some of you are you're going to love this type of question. This is called a pathways question. And I really like pathways, so I always put this on the test. Because it's all I gotta do is just make up a grid with rectangles. I just gotta make up a rectangle. I'm going to show you 2 different ways to solve this. And then to see if you understand this, we'll draw 2 different other examples to see if you guys are going to be good at this. Paul and Catherine are considering the following problem. Find the number of roots from A to B if you must always move closer to B. So imagine that a person is standing right here and they've got to walk to B. And they're like, how many different routes are possible? So I'm going to show you, before we do this, I'm going to say, you guys, let's say I move B here. If I said how many different routes are possible to go from here to here, the answer is 2, and I'll show you. The person could go this way, and that's 1 route, or they could go this way. Do you guys agree? So if I just gave you a square and I said, how many routes possible to get from A to B here? There's 2 routes. What we're going to figure out is how many routes are possible in this rectangle, A to B. Okay, so there's 2 different ways that you could solve this problem. And the first method is counting. So method number 1 is counting. And each of you are going to have a preferred way. When you're counting, what you do is you put little 1s along the top and the left-hand side at every sort of hatch mark. So I'm going to put a little 1 here, a little 1 here, a little 1 there. And I'm going to put a 1 here, and I'm going to put a 1 here. To figure out how many routes are possible to get to this point here, what you simply do is you add the diagonals. So remember how I said there was 2 routes to get to here? There's 2 different ways we could get to this point. How you got that is by adding up the diagonals. 1 and 1 is 2. If I said, okay, what number would you write here? You add the diagonal, 2 and 1. There's actually 3 different ways to get to this spot here. So 2 and 1 would be 3. How many different ways are there to get to this spot right here? 2 and 1 would be the diagonal. There would be 3 different routes to get to that spot. Continue adding your diagonals. 3 and 3 is 6. 3 and 1 is 4. The answer to get from A to B, there are 10 total routes. Okay, so this is counting. I should actually write counting by hand. So counting by hand, there are 10 routes total. The second approach that you could take to this question, and you get to pick, like I said, which one you like better, it's called the repetitions approach. So the repetitions approach. Okay, so how you're going to look at this one is you're going to say, okay, to get to A to B, the repetitions approach would be saying you're going to go 3 units east and 2 units south. So the repetitions approach would be how many total movements are you making? So think about like a word. There's 1, 2, 3, 4, 5 letters in this word. So 5 total movements divided by the repeating movements. So you're going east 3 times and you're going south twice. Let's just do this one by hand. 5 factorial, let's unzip it until we get to 3 factorial. So 5 factorial is 5 times 4 times 3 factorial, just so we can do this in our head. That's being divided by 3 factorial, 2 factorial. 3 factorial will cancel. And what we have is 5 times 4, which is 20. 20 divided by 2 is 10. There's 10 routes. Okay, just because I like this question, and it's going to be on your test, let's do 2 more different rectangles. So I need you to find in your workbook somewhere, like maybe flip to the beginning or the end, wherever you guys have those blank pages. And I want you to draw, we're going to do 2 more. I want to do it by counting by hand and the repetitions approach. So draw yourself a rectangle, and I want your rectangle to have 1, 2, 5 columns and 3 rows. So read, it's just a blank sheet of paper, like just find a blank that you could draw yourself a rectangle with 5 columns, 3 rows. Don't worry about it being pretty or anything like that. Because in your homework you'll have nice rectangles and the test will have nice rectangles. Okay, so the first method is by hand, and we're counting. So what you want to do is you want to put little ones along the top and the left-hand side at each little hatch mark. So you'd say 1, 1, 1, 1, 1. Then you're going to do the same thing going to down the left. So 1, 1, 1. How many ways can you get to this point here? Well, there's 2 ways. I could go this way or I could go this way. So how I got that is you just add the diagonals. So 1 and 1 is 2. Then add these 2 diagonals. 2 and 1 is 3. Add these diagonals. 3 and 1 is 4. So to get to this point down here, there's 4 different ways that we could actually get there. Okay, let's continue adding the diagonals. So 2 and 1 is 3, 3 and 3 is 6, 6 and 4 is 10. 3 and 1 is 4, 6 and 4 is 10, 10 and 10 is 20. 4 and 1 is 5, 10 and 5 is 15, 20 and 15 is 35. 5 and 1 is 6, 15 and 6 is 21. The answer to get from A to B is going to be 35 plus 21, which is 56 pathways. The second way, if you don't like counting by hand, is the repetitions approach. So I'm just going to erase this. To get to A to B, let's count the total number of moves that this person would make. So 1, 2, 3, 4, 5, 6, 7, 8. That would be 8 factorial. Then the repeats. This would be like an east, 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 east. 1, 2, 3, 4, 5 movements east. 1, 2, 3 movements south. You could type that into your calculator, or we could quickly unzip it and solve this. 8 factorial, I'm going to reduce till I get to 5 factorial. So 8 times 7 times 6 times 5 factorial. All over 5 factorial, 3 factorial. 5 factorial, 5 factorial cancel. You guys, what was 3 factorial? 6. So I'm going to cancel 6 and 3 factorial. 8 times 7 is 56 different ways that you can get from A to B. Let's complicate this by putting one rectangle onto a second rectangle. So here's what I mean. This guy. Can you please draw this for me? And then if you could do this one as well, you could do any rectangle I give you. And you will not get this question wrong. And we're going to do the 2 different ways. We're going to count and we're going to do the repetitions approach. Okay, so what I want everybody to do right now, let's start with the counting method, and let's do the by hand. Everybody should be able to get to here. So can you guys get to that point for me? And then I'll show you what you do when you get to that point. So I haven't showed you what we do when we extend a second rectangle on, but everybody should be able to figure out how many rows there are to get to there. So I'm going to put my little ones up on the top and on the left. And then I'm going to add all my diagonals. So 1 and 1 is 2. That guy would be 3. This guy would be 4. That guy would be 5. 2 and 1. There's 3 ways to get to that spot. 6 ways to get to that spot. 10 ways to get to there. 15 ways to get here. And then we're going to continue counting. There's 4 ways, 10 ways, 20 ways, and 35 ways to get here. Just by a show of hands, how many of you got to 35? Okay, so if you start here, and then you get to here, there's 35 ways. If I say, well, how many spots would it take to get to here or here? The answer doesn't change from this 35. So what we do is once you have a second rectangle joined on, when I say fill the top and the left-hand side, you're not going to put ones up here because what you're saying then is to get from here all the way to here, there'd be 1 way. That's not true, right? We know to get from here to here, there's 35. So if I say, okay, well now just move to here, there's 35 ways. So you take that 35 and you just carry it across and you carry it down. So if there's, let's say 100 ways to get here, on my second rectangle, I put 100, 100, 100, 100. That's all you do. Whatever ways there are, you carry that. Now do your diagonals, and you're going to have your answer. So add your diagonals. 35 and 35 is 70. 70 and 35 is 105. Okay, then I've got to do over here. 70 and 35 is 105. And now I've got my answer, because to get to this last spot, 105 on 105 is 110. Nope, 210. So counting, there's 210 rows. Or 210 different ways that you could get from this point to this point. Okay, let's do the repetitions approach. So the repetitions approach, there's 2 different rectangles. So repetitions approach, we want to do rectangle 1, and then they have to go to rectangle 2. So for rectangle 1, count your total number of movements to go from here to here in rectangle 1. So you would say, okay, 1, 2, 3, 4, 5, 6, 7 different movements to get from here to here. So you'd say 7 factorial. Then you would take care of the repeats, and the repeats are 3 factorial divided by 4 factorial. You would figure out what rectangle 1 is, and the answer that you should get would be that 35, right? So you should get 35 here. What does the word and mean? You multiply, because you're going from here to here, and then you got to get to here. It's not or, right? It's and you got to go through here. So then that you would multiply, and you got to figure out the second rectangle. So the total number of movements in the second rectangle
is 1, 2, 3, 4, which would be 4 factorial, all over 2 routes, 2 ways east, 2 ways south. And you figure out that. So you do the first rectangle, find that number on your calculator. Second rectangle, find that number on your calculator. Multiply those 2 numbers together, you should get 210. So you should be getting. Everybody's getting that? What's your favorite way? Haley, how are you going to do this on a test? Repetitions. Gabby? Yeah? Nobody's going to do the counting method? I'll show you on Monday when you would have to do the counting method, but it's if it's not a perfect rectangle. You would never get a non-perfect rectangle in 30-1. In 30-2, they do a unit like this, and they would get non-perfect rectangles. So I'll show you an example, though, on Monday. Okay, can you guys please write your homework down? So homework is questions 6 through 12. For number 9, you don't have to use C. Number 11 has the 2 rectangles going together. Number 7 is just 1 big rectangle. The book teaches the repetitions approach. That's the only way the book does it. They don't show how to count. I like counting.